So first job on part 3 here is to take a look at curves transformation. What we'll take a look at, putting another mask on the image. Masks are important. Masks enable you to protect things you don't want to affect. There's black and white image. And again we'll go into histogram transformation, our friend, reset that. Click the tick box, make sure we're working on the luminance, this mask we're going to use, and scroll out. Alright, we need to do that and reset it. Reset that. There we go, that's better. Getting lost there. And what we'll do is crush this image down. We need to turn on the real-time preview to see what we're doing. Crush this image down like this. Put a bit of a stretch on there. Because I think the portion that I really want to work on is this area here. And we'll apply this to our mask. Shut down histogram transformation. Drag this tab over here, and that applies. Whoops, I missed. That applies this mask to this image. Minimize your mask. And we'll turn the mask on, show mask. See what we're actually protecting at the moment. You can see we're pretty much protecting the background. We don't want to protect the background. We want to unprotect the background. I'm going to invert the mask. I don't want to work on these stars or anything like that. And what we'll do, we'll show mask. And then we'll go to curves transformation. Click the tick box. Turn on real-time preview. And then what we're going to do is just work on this background a little bit. We click in here, you'll see the background is this point here. We click on a star, you'll see that star is marked way up here. So we're going to put some markers on here just to protect what we're doing. So these areas shouldn't change. I'm going to apply another mark there, another one there. And the background area here we were looking at, about there. So I'm going to get hold of the line here and just drag this down slightly. Like that. Yeah, it's coming, getting there. Shut down that, the real-time preview, and drag this over the image. This is now going to apply that little stretch we've done to our main image. There we go. As you can see, things are starting to look a bit more like the sky. Looking a lot better. Now I'm going to invert the mask. And I want to try and bring out this redness a little bit. But you have to be really careful what you're doing with stars at this point. With the mask inverted, everything we do here will also affect the stars. So this comes with its own set of challenges. So click on the S button here. This S stands for saturation. And bring up our real-time preview. In fact, let's put a small preview on that area there. And look at this area with the preview on. There. Now what I like to do is bring out the redness around here a little bit. And if I click on what you can see on that redness there, you can see where we've got to attack. About there. If I click on the blackness, you'll see we don't want to touch the blackness. And if I click on the stars, you'll see, well, they're way off the chart. So I'm going to put some markers on here so they don't move when we start changing things. Click back on that to make sure I've got the right spot. Just there. I can put another one here. So the line doesn't bend. If this bends, if I was to just drag this, then the whole line would curve. But if you put these markers on, then it just stops that part from moving. Of course, in theory, that protects certain areas of the image. So I'm going to grab there. I'm just going to move that up while we watch the real-time preview. And you should see redness starting to appear. Is it a little bit of red? No, it didn't actually change anything. Let me just reset that all back. I'm just going to throw this up to see what happens. No, not making much difference at all. Okay, let's shut that real-time preview down and just invert the mask. It's, as you saw, it's quite difficult, this mask, so it just may be protecting it so much that it's not changing it. We may have to create a new mask for it. Let's just put the real-time preview back on, drag that up. Ah, now we're seeing it. Right, okay. So again, we need to protect the areas down here we don't want to move. The areas up here as well. And okay, where we are. Yeah, should move that one there. We want to move that up. Now we can see some redness starting to come through. I untick it. See the redness is there. You don't want to go too crazy when you're doing this. Subtle changes, if possible. Right, now we'll drag that triangle over the preview window here and see what it does. And using this little box up here, we can turn the preview on and off. Yeah, we've added some redness back into the parts that we want to be red. So back to the full image. Drag the triangle over the full image. Now this is the important part that we pay attention to what happens to the stars. We don't want them to go blown. The term is blown out. We want to blow the stars out. So there we go. We're getting there. And I think what I'll do is I'll also run the curves transformation again. And we'll have a look at the lightness component. See if we can just reduce things a little bit too crazy. So I don't know if you can see when we do that, stars get affected slightly by it. But yeah, that's made that a bit blacker. So we'll put this stretch now onto our main image. Right, what I'm going to do is, after I've turned my audio back on, I did that with my mic turned off. Okay, let's start that again. What I'm going to do now is I'm going to apply the annotation that we did earlier to this image to see what we're looking at. I'm just going to show you something quite interesting. So we're going to script, render, annotate image. And we just click OK on that. What this will do is it will produce an image with labeling on what we're looking at, which I've shown in previous videos. And there's the annotation. Now you can see that what I did was align or polar align the telescope to actually look at IC 1396, which is actually dead center of the image. But all the interesting stuff appears to be over on the right hand side. So what I should have done when I did the image, I didn't know this at the time, but I will do for future images, is actually image at this point here, which is quite easy to do with my software that I use that controls the telescope. Anyway, it is what it is. We've got this now. So I'm going to shut down the annotated image. Don't need that at the moment. And what we'll do, we got a mask on this. Yes, we have. I'm going to just try and improve the redness just a little bit more using our curves transformation. I don't know if I'll be able to bring any more out. So we need to put a preview box on there. Okay. Real-time preview. Go to the saturation, the S at the end here. Just drag that up. Let's just see what happens. It's gone red, but it's a bit it's a bit OTT for me. Just drop that down a little bit. If I take it down the other way, you'll see it goes less red. But I like to have it a little bit redder than it is at the moment. Which I reckon is about there. Now we'll drop that curves transformation onto the main image. Let that run, see what happens now. Again, I'm looking at the stars as well, because you don't want to start blowing out your stars. Takes a little while. Right, there we go. That's looking not too bad, I guess. Move that preview. Yeah, too bad. Now, is there anything else I want to do to this? I could put star mask on it and reduce some of the star sizes. But I think I'm going to leave it at that for now on this particular image. So let's just remove the mask. All right, I'm going to save this image. And also, something I noticed when I zoomed in is I kind of liked the way this looked. Like that. Is there anything else to do to possibly? Let's just try one thing. Don't know how well this will work out, but I'm just going to try running a process on this part of the image just to see how it looks. So we're going to put a mask, another mask on, reapply mask, a new mask. So I'm just going to throw this mask on here because I just want to try something. I don't know if you're familiar with the software I'm using, PixInsight, are you, by any chance? Right, let's just try it. Gonna put a preview on that. Bring that area out. Right, what I'm going to do here is I'm just going to run a process on this. I don't know if PixInsight would be any good for you. I mean, a lot of astrophotographers use Photoshop. I have Photoshop and I can use it. I use the or whatever it is, the latest one that you pay a monthly subscription for. I use Photoshop, but I found that using this dedicated Astro software is a lot better. It's more detailed in what you can actually do with the images. But people that can really use Photoshop can do just as good as this, in my opinion. I've seen some really nice things produced by Photoshop astrophotographers. So what I'm going to do is I'm just going to try what is it? HDR multi-scale transform, just to see if I can possibly make this a bit different. This image is half a gig in size. Hold on, I'll show you. Just find the right thing. If I go to processes and rescale, I think it is. No, not rescale, the other one. Resample. And I choose the image here. You'll see how big it is. It's 8,272 pixels by 5,362 pixels. And it's about half a gig, this particular image. In fact, I can probably show you, have a look, see how big it is. Yeah, that one there. 520 meg. Some of them get quite large. And typically when processing, I'll use 30 to 50 gigabytes in storage space to actually do the processing, because of all the little processes that go on in between actually looking at the image. But that's how big it is. But what I'm going to do is just run this HDR multi-scale transform on this preview. See if it makes any difference to my image. I'm not sure if it will. This is quite intensive, so I might buffer a bit while this is running. Not sure. Actually, my image doesn't look too bad on the preview screen in my broadcasting software. Looks quite nice down there. Right, how did that work out? Let's have a look. Step it back. Yeah, you see if I've got an undo, redo button here. Not. Yeah, I don't like it. Just wind this up to 8. Try it again. I don't really like that. Probably going to leave the image as it is. On the stars. That's no good, is it? I don't like that one little bit. Right, I'm going to leave it like that. You can do spectroscopy on the stars. Let me read what you said. Right, I get you. Yeah, of course. This is I kind of did the same thing. We run a process on here called drizzle integration, and when you drizzle the image, it actually comes out twice the size that it started at. And what it does is it takes the pixels that are bad and are containing possible noise, and it guesses at what they should be. And this is a process that I use called drizzle integration. So it's kind of similar, I guess. But with astrophotography, if you've got a camera, you can actually do quite a lot with what you see, because all you have actually got is light. So you can run spectroscopy on the light. Oh, God, I bet. I don't even want to look at that. Maybe you can ask her when she gives your talk. If she, whereabouts are you in the world? Did you say you're at, hang on, scroll back on the chat. You're at university, so you're doing university postgraduate stuff or whatever it is before you graduate? But yeah, you'll enjoy that if you're into that sort of thing. Okay, cool. Well, yeah, I mean, it'll be interesting to listen to what she says, especially if you can ask her that question. Did you use any reconstruction algorithms? Because okay, well, I'm sure the reconstruction algorithms, like in what I've done here, guess at certain things. I'm imagining. I don't know. But I'm pretty much done on this image here. I'm not going to throw anything else at it. Because the whole key with astrophotography is you have to collect good data. Right, I gotcha. You have to collect good data. And if you don't have the good data, you just end up with, bad result. This image is quite a hard one to do for me. It's always been one of my troublesome ones because of the amount of red up there. And red is a good thing. The camera that I use it's an old Canon 450D DSLR, but it's had the red filter removed from it. So if I was to snap a photograph with it in the daytime with a normal lens on it, it would have a red look to it because the filter's not there. And the whole point of that is so I can get the red coming through from space. So that's really cool. I've had some interesting chats on here actually. I had a guy on here the other night who he's measuring at uni also. He's measuring the temperature of the Earth. I think to do with global warming. That was quite interesting. He was quite an interesting guy to talk to. So, but that's the bigger image there. That's actually the red. The red is actually hydrogen alpha. It's hydrogen up in space. It is. It's not just something I've put there. It's hydrogen alpha. Let me show you an image. I'll show you an image which I took a while back. It actually took me 3 months to make this particular image. This one here. This is my website, and this is at this time of the year. If you bend your neck back, there's a star. That's the brightest star up in the sky, right above your head. And that is this star here. It's called Sadir, and it's in the Cygnus region of space. And this is an image that I took over the course of about 3 or 4 months. And it's comprised of there's 3 images here that are mosaic together using the software. And all this redness is hydrogen alpha. It's hydrogen. And what happens is the brightness of the stars, they kind of ignite or they show up the hydrogen. But this star here is right above your head at this time of year. It's Adir. And this actual image is 4.5 meters high. If you were to print this, but obviously we're not going to print it. And you see all sorts of other stuff like this thing here, which is the Trunk Nebula. There's all sorts of things floating around up there. But the redness that you see is hydrogen, and there's a lot of it up in space. And that's what's causing this redness in here. It's all over the Milky Way. So, and that's where this one is located. Let's just get a bit more information about it. I'll read you what it says on the wiki, so you know I'm not making it up. In fact, I'll put the wiki on the page there. It's a concentration of interstellar gas and dust. There you go. It's called the Elephant's Trunk Nebula. And the bright rim, in other words, this rim around here you can see, that there. That's the surface of the cloud that's being illuminated and ionized by a very bright star, which I think is one of the, I think it's this one here. One of these here is lighting all this up. So you see the redness of the hydrogen coming through. And that's what causes all this stuff. And there's other, you know, there's oxygen up there, oxygen, and there's, well, it's called O3. It's wrong of me to call it pure oxygen. It's not obviously not pure oxygen, but it's called O3. And you also have sulfur 2, which is another emission out of space. To get the images using hydrogen alpha, say I wanted to add a hydrogen alpha to this image, I'd have to do another night imaging with a hydrogen alpha filter on the camera, and then integrate that into the image. Then you see more stuff coming through. So it's pretty cool, and it's real. It's not fake color or anything like that. This is actually photograph. A lot of people say, "Oh, what's that? How did you do that? Did you Photoshop that with lots of color?" No, it's just I can turn the color up and I can turn the color down, but that's, you know, you got to try and strike a balance between the blacks, the reds, and the whites, and everything. And also, obviously, you've got different color stars. You can see this star here. I don't know if you can see that red star there. That's probably a supernova. That star looks like a star. You get in a bit closer. It's probably a supernova. But you won't find any astrophotography guy. You know, we can't change it. We've got it's photographing what's up in space. We can't add stuff. We can take stuff away. I can take stuff out of there, but I can't add stuff. And the color is what it is. It is what it is. And you can see the different colors on the stars. You've got red stars, blue stars, white stars, and that's using spectroscopy. That's how you can determine if that star is moving away or towards you, and also what speed it's moving at. Unfortunately, I can't afford the equipment for that. Maybe if you've got an astrophysics lab in your place there, in your university, you can wander down there and have a look and see what they're looking at. I don't know what it's like for you guys, whether you can just go and poke your nose into what some other guy's doing, or girl. I don't know. So yeah, that's about as much as I'm going to do on this. I've been at this for an hour and a half now. The previous stream that I did was 5.5 hours, and that was the actual pre-processing, because obviously when you get where did it go? It's weird. When you get a group of images like I showed you, in here. These are other images I'm going to be processing. When you get a group of images like that, and like that, you have to combine them all into one image, and that's a trick in itself. That takes a long time. It takes normally longer to do the processing than it does to actually take the images, because you've got to build all this into one image by stacking them, and also looking at them to make sure there's no satellites or planes or anything running through the image and causing a white line. So I'll just show you another image that I did. It's called the Wizard Nebula, which is quite a fun image. Can I open that image? No, I can't. Can I open it? Yeah, I can open it. Hold on. I'll show you a couple more. There's a funny one. This is the Wizard Nebula. And you can see again redness, but humans like to see patterns in images, and that one that I've been doing tonight, that's the elephant's trunk nebula, because it looks like an elephant's trunk. This one, if you look carefully, looks like a wizard. You can see his hands here, holding his hands out, his nose and his eye and his hat. Now if I apply hydrogen alpha to this image, then you see the hat more distinctly, all sorts of stuff more distinctly. But there's the Wizard Nebula, and another one which we did, which worked out kind of okay, but I only did 25 images of it, and that was a galaxy called the Bode's Galaxy. And that's a galaxy up in space. That's actually, if you know where Ursa Major is, I think you call it the Big Dipper in the States. This is off to the right of the Big Dipper. Actually, look at it in the sky. But obviously you can't see it with your eyes. You have to take lots of images and then process it. So yeah, it's pretty cool, all this stuff. And you sometimes see interesting stuff. You can take some really cool images, and we all dream of the times when we go through our lights, all the images that we take to produce these images, all the separate images. All these, they're called lights or subframes. Before we process them, excuse me, we have to go through each one to make sure there's nothing nasty on there, no satellite trails, or the exposure's looking reasonably okay, not too bright. We dream of the time when we see something flash across the screen. But we don't see it. These images have been the same for thousands of years. I've actually got one of I don't know if I can show it. Maybe. I don't know how good my search engine is on my website. You type in fish, because I compared it to fish. Yeah, here it is. You can see it here. There's a this is a great globular cluster in Hercules. All right. Now I annotated this image to show you, to give an indication of what else is up there. And if we click on that image, I'm not sure if you'll be able to see it on the screen. It'll take a little while to load. And this is all a time machine. Every one of these circles is a galaxy. just like ours. Yeah. Some are different distances away. This isn't a galaxy. This is a great globular cluster containing lots and lots of suns. Hundreds of thousands of suns. But this spot here, IC 4617, you can't actually see it. It's a really tiny, tiny little smudge on the screen, on my screen when I'm processing it. But this spot here, the actual image is 500 million light years away, which means basically when that light left there, we were still fish in the sea.
Yeah.
If you believe in that. I do, but there you go. But yeah, the light left here 500 million years ago, which is it's like having your own time machine. And we all always hope to see something change on these images, because I image this every year or every couple of months. I'll image it, but nothing ever changes. It's always the same. I don't know if I can get in any closer on that. Maybe I can. Hold on, let me just I'll copy the image location and stuff it in there. Maybe we can get in closer. Yeah, it's there. It's a tiny little smudge in that crosshair. Obviously, I don't have a Hubble telescope, so I can't see it very well. But that's 500 million light years away. Just there. So there we go. Interesting stuff, eh? But what I'm going to do is I'm going to shut down the stream because it's 12:30 at night. So yeah, anybody else here, including you, Eric? Thanks for coming. Thanks for watching, and we'll see you all later for the next image, which will probably be done in a couple of days' time. So see you all soon.